Yo, let's look at the apple redistribution problem from LeetCode. The problem number is 3074 and the difficulty is easy. The video is divided into parts, so feel free to skip around. Let's firstly try and understand the problem. We will be working with two arrays. One is called apple and the other is called capacity. The index in the apple array would signify a packet of apple. So the 0th index would mean the first packet, the first index would mean the second packet, and so on. The value on that specific index would signify how many apples there are in that specific packet. Let's say we have 2 packets of apples, and the first packet has 3 apples while the second packet has 5 apples. The array would look like this. The capacity array is rather similar. Each index represents a box. Index 0 represents box 1, index 1 represents box 2, and so on. The value on a specific index would tell us the amount of apples that box can hold, its capacity. Let's say we have 2 boxes. First box can hold 7 apples, but the second box can only hold 3. The capacity array would look like this. So we'll be given both of these arrays of unknown sizes, and it's our job to take the apples out of the packets and fill the boxes up. But we have to try and use the minimum amount of boxes possible, filling up each box to the maximum it can hold. Let's further understand it visually by looking at an example. Let's assume we have 4 packets of apples and each packet has 8 apples. Then let's also assume we have 4 boxes and the amount of apples each box can hold is written above it. Now, let's figure out the minimum amount of boxes we need to fill up before running out of apples. Well, let's first figure out how many apples there are in total that need distribution. In this case, there are 32 apples. We pick a box, any box, and fill it up with apples. But if we pick a big box, one that can hold a lot of apples, we will end up using few boxes overall. Do not feel overwhelmed if you did not understand that. It will become more obvious later on. So let's pick the biggest box, the one that can hold 20 apples. After we pick that and fill it up with apples, the total number of apples would decrease by 20. So the amount of apples that are left that still need to be distributed are 12. Now, we already picked the box that could hold 20 apples, so let's pick the next biggest one. And that box happens to be a box that can hold 16 apples. We only need to fit 12, so we take the 12 apples that are remaining and we put them in the box. After we do that, there are 0 apples remaining. Even though that box is still not full, our job is done, because we have distributed all the apples that were available to us. And how many boxes did we use? Only 2. The box that could hold 20 apples and the box that could hold 16. Now what if we picked all 4 boxes? First we filled up the smallest box and worked our way up. If we did that, we would have used 4 boxes to fill up 32 apples. But 4 boxes is not the minimum amount needed, as we can get the job done with just 2 boxes. Similarly, picking boxes randomly would not ensure us using the minimum amount of boxes. Let's get into the code. We have one function called minimum boxes, and that will return the minimum amount of boxes required to distribute all the apples. We're using vectors as they make life simple. However, you can do this with normal arrays. It will just be a lot more code, and you'll also need to pass the sizes of the arrays. Alright then, what is the first thing that we had to do? That's how many apples in total do we need to distribute? A simple for loop where we iterate between each element of the apples vector and add it to a sum variable will get the job done. Next, we need to select the biggest box. Let's say the capacity vector is as follows: 5, 10, 3, and 30. We'll have to traverse the vector, find the largest box, fill it up, and then traverse the vector again, finding the second largest box, and so on. That is a lot of time that we are wasting. Instead, we could sort the vector in ascending order. So the capacity array would then become 3, 5, 10, 30. Since it's sorted, the last element will always be the largest. Therefore, the last element will be the largest box, and the element before that will be the second largest, and so on. So we'll call the inbuilt sort function and pass in the vector's beginning and ending. Right then, now we have a sorted capacity vector, and we know that the last index will always have the biggest box, and the indexes before this last one will have the second biggest, and so on. Therefore, let's store the last index in a variable, j. The size function returns the size of the vector, and since indexing starts from 0, we need to subtract 1. Also, let's have a counter variable to count how many boxes we end up using in total. At the start, it's going to be 0. Alright, we've done all the prerequisites and can now move forward with the main functionality. At the start, we have to pick the biggest box. After we fill it up, we pick the next biggest box. So we will be going down the vector. Therefore, we need to use a loop. I'll use a while loop. You can do this with a for loop as well, it doesn't matter. The terminating condition in the while loop is j more than equals to 0. That means as we're going down the vector, we will keep going down as long as we are either above or equal to 0. If we go into the negative values, we will break the while loop, as negative indexing is not a thing. Now, when we pick the biggest box, one of two things can happen. The first thing that can happen is the size of the box happens to be exactly equal to the amount of apples we need to distribute in total. If that's the case, we'll simply increment the amount, the count, and return the value since all of the apples will fit into that one container. The other thing that can happen is the size of the box is not equal to the amount of apples. If that's the case, we will increment the count and fill the box up with apples. After we fill the box up, we can remove the size of the box from the total number of apples to get the remaining apples that still need to be distributed. In the example we did earlier, at the start, total apples will have 32, and the capacity of the largest box will be 30. So we fill the box up, meaning we remove 20 apples from 32 and end up with 12 apples still remaining to be distributed. When we are subtracting, two things can happen. First, the remaining apples becomes negative. That means the box that we used was bigger than the amount of apples we had to store. For example, we had to store 10 apples, and the biggest box available was of size 30. That means the remaining apples equal to 10 minus 30, which is minus 20. That still means we have filled up all the remaining apples, but our box is not full. Our box not being full is no concern to us. Since we have distributed all the apples, our job is done. We simply return the count. The other thing that can happen is the remaining apples is some number greater than 0. That means we need to use another box to fill up the remaining apples. Therefore, we will go down the capacity array, pick the second largest box and fill it up. Then check the remaining apples again and go down the capacity array if need be, and keep on doing this until one of two things happen. First, we use up all the apples or it gets negative. And the second thing is we have traversed the whole capacity array. Therefore, the value of j, the index, is less than 0. At the end, if we have gone through the whole capacity array and there are still apples remaining, we simply return the count as we have used all the boxes that were available to us. Therefore, the minimum amount of boxes we can distribute is the number of boxes available.